wondered why maths matters outside of school? Spoiler, it kinda shows up everywhere. In this video we're going to break down some key mathematical concepts clearly and simply. Whether you're studying, relearning, or just curious, you're in the right place. Please remember to like and subscribe, I really appreciate the support. Let's get into it. Okay, let's look at finding the dot product now with a k unit vector added into our rectangular components. A is equal to I minus 2j plus k, and b is equal to 4i minus j plus 3k. Well, to find the dot product, if I have ij and k's, or just i's and j's, it's the exact same process. So if I have a dot b, I'm just simply going to multiply my coefficients of I, which in this case is going to be 1 and 4, my coefficients of j, which will be minus 2 and minus 1, and my coefficients of k, which will be plus 1 and positive 3. So if I do that, that is going to be 1 multiplied by 4 plus minus 2 multiplied by negative 1 plus 1 multiplied by 3. Well, 1 times 4 just gives 4, minus 2 times minus 1 gives positive 2, so that's going to be plus 2, and 1 times 3 simply gives positive 3. 4 plus 2 is 6, 6 plus 3 gives me a dot product of 9, and it's all the same geometric interpretations. The dot product is mainly used to find the angle between vectors. If my dot product is 0, it means my vectors are perpendicular, or the angle between them is 90 degrees. So a dot product value of 9 doesn't really tell us a lot. It tells us it's not perpendicular, which can be useful to know, but mainly application of dot product is going to be using this result alongside some other mathematics to find the angle between two vectors. So dot product is really useful. This value of 9 here though, on its own, doesn't really tell us anything other than these two vectors A and B are not perpendicular. When it comes to finding my angle between two vectors, I want to be considering my scalar product. On the formula sheet, we are told A dot B, the dot product between A and B, is equal to the magnitude of A multiplied by the magnitude of B cos theta. This is why if my dot product equals 0, cos theta, or theta, must be 90 degrees, because cos of 90 degrees is equal to 0, so therefore A dot B should equal 0. So this also kind of supports the idea that my dot product equaling 0 means my two vectors are perpendicular. Now, in this question, when it comes to finding the angle between my two vectors, normally I want to rearrange to make this cos theta part the subject. So if I rearrange my equation, that gives me cos theta is equal to A dot B, all divided by the magnitude of A multiplied by the magnitude of B. So to find my angle between two vectors, I need to find the dot product of A dot B and the magnitude of A and the magnitude of B. Well, let's start by finding the dot product between A and B. So to find my dot product of A and B, I want to multiply my I coefficients together. That's going to be minus 2 times 1. That's simply just going to give negative 2. I also want to multiply my J components together. Well, minus 3 times minus 1 gives positive 3. So it's going to be plus 3. And I also want to multiply my coefficients of k. That's going to be 1 multiplied by 3, which also gives plus 3. Well, minus 2 plus 3 gives 1. 1 plus 3 gives a dot product of 4. So I've now found the number that needs to go here. I found this number that needs to go on top of my fraction. So now I just have to find the magnitude of A and the magnitude of B. Well, I know to find the magnitude of A, that is simply going to be the square root of my coefficient of I, which in this case is going to be negative 2 all squared, plus my coefficient of J, which is going to be minus 3 all squared, plus my coefficient of K, which is going to be 1 squared. Well, that means I'm going to have the square root of negative 2 squared is going to be 4, plus negative 3 squared is going to be 9, plus 1. That is going to equal the square root of 14. Okay, now I'm going to find the magnitude of B, which again is going to be equal to the square root of my I component, which is going to be 1. So it's going to be 1 squared, plus my coefficient of my J component, which is another minus 1 squared, plus my coefficient of K, which is going to be 3 squared. Well, 1 squared is just 1, negative 1 squared is just 1, and 3 squared is going to be 9, which gives me the square root of 11. So I found A dot B, I found the magnitude of A, I found the magnitude of B. I'm going to put all of these numbers back into my formula. So A dot B was 4, the magnitude of A was the square root of 14, and the magnitude of B was the square root of 11. This is going to be 4 over the square root of 150
154. And 4 over the square root of 154 is a bit of a weird number, so I'm going to be needing to use my calculator here to find theta. Well, that means that theta is going to be equal to cos to the minus 1 of 4 over the square root of 154. And if I type all this into my calculator, I get an angle of 71.2 degrees if I round to 2 decimal places. Or if I want to express my answer in terms of radians, that also does give me a value in radians of, and I'll put this part in green, of 1.24. And I'll use that kind of little, almost like a mini c to represent radians. So the angle between vectors A and vector B is 71.2 degrees or 1.24 radians.